Okay, is it recorded? Yeah. Okay, what up, peeps? Today we're going to go over the last form of elimination method, or solving a system of equations using the elimination method. Now, when you go to high school, though, this method is going to be called the substitution method. And I'm going to tell you straight out, this is probably the most difficult method out of the other two that we taught. We taught you how to graph. We taught you how to do the elimination method. Then it's the substitution method. Again, the substitution method is probably the most challenging one, the most difficult one. I don't teach a substitution method. I kind of make my way around this by making the problem become an elimination method problem. So that's what I'm going to show you today. And it's been very successful every year when I teach it this way. Okay, so here's a poster outlining all the steps. Probably after looking at this poster, you're like, wait, there's a new step embedded in there. And you'll find out which one is it. So copy that one. That one's on your notes. Copy it down. Copy it down. So title it, Elimination Method, Part 4 in your notebook, red pen. And then copy the problem down in red as well. I know this is in black, but so you're going to be able to see it in the video. So once again, this is a system of equations. There's 3 scenarios, and hopefully you remember your scenarios. You don't have to copy your scenarios unless you forgot them. So you have a popular scenario called intersecting lines, which is basically one solution. Then you have the other scenario when you have parallel lines, which is no solution. And then you have the last scenario, which is overlapping lines. When you have 2 lines that literally are on top of each other, that's many solutions. Okay? So you have 3 scenarios for a system. Looking at this system, we have to decide how we're going to solve it. You already know how to do this. If you look at this, you're like, wait, it looks kind of weird. This problem looks weird. So go through your steps. First step is, can you graph it? Well, I can't graph that one. That one's in standard form, so I can't graph that one. This one seems like I could graph it. No, it's not in slope-intercept form. It's similar to slope-intercept form, but it's not. But you might have an idea how to graph it. But you can't solve it though by graphing though, because in order for you to solve it by graphing is, you need to know how to graph both of them. So graphing doesn't work. But just look at this. This looks different compared to the other problems you've done so far in class. Hopefully you can see the difference. Let me just write this. Don't copy this. Don't copy this. Let me write you a problem that we're normally used to seeing. They're stacked. They're stacked up. The x's are stacked up together. The y's are stacked up together. The equal sign is stacked up together. And then the constants at the end are stacked up together. Everything's nicely orderly in an organized fashion. Let me ask you this question. Are these nicely stacked up? Are these equations in the form that we normally have them for elimination? Well, hopefully your answer is no. Hopefully you agree with me that this first equation is, right? This first equation is correct. You have both, because look, if you look at this setup, you have all the x's and all the y's on the left side. Do we have all the x's and the y's on the left side? On the first equation, on this one? We do. So that one's good. So let's recopy this one. 3x plus 4y equals 8. Let's go look at the second equation. This one. Is both the x and the y on the left side? Well, the x is good, but not the y. So we're going to have to move this y over to the left. We have to move this y over to the left. Okay? So, first of all, before we start doing that, let's line up stuff. Let me use this one. Line up your equal sign. They line up. Is the x on the left side? Yeah, it is. It's good. So, the x will go over here. The 8. We normally have the numbers, the constants, always to the right side. Is it already on the right side of the equal sign? It is. So we put it there. It's that 4y that's bothering us. That 4y needs to move over here. It needs to move across the equal sign. But you cannot just do this in math. You cannot be like, okay, you want me to move it over here? Let me move it. There. Happy? We're done. Nah, you can't do that in math. Heck no. You can't do that in math. Okay? Remember the barrier? This is the reason why I teach barriers and all that stuff, where there's an equal sign. The equal sign prevents this for y from doing that what we just did. So in order for you to jump the fence and come to the other side, what do you have to do to this sign? You have to change it. So you have to change that minus 4y, minus 4y. So in order for that one to move over here, it has to switch a sign. So instead of being a positive 4y now, it's going to be a minus 4y. And look at that. Boom! Does that look like the elimination problems that we've done before? They do. That's it. The only thing you do is, okay, move this one to the other side. In order for you to do that, just switch the sign. That's it. You really don't have to show this. I'm just showing you that so you understand what's up. So then you just move this guy over, and that's it. Change the sign. Beautiful elimination problem. Go through your steps again. Can you graph them? No. This is a new step I added. Do the equations have the same form? Do the equations look like this? If they do, then you could keep on doing elimination. If not, fix them. We just fixed them up. That one, we just fixed it up right now. Next step is, it's like elimination method now. Do any of the variables eliminate right away? Well, the x's don't eliminate. Don't forget that there's one here. These don't eliminate, but wait, look. These eliminate. So, boom, boom, cancels out. Keep on going. 3x plus 1x is 4x equals 8 plus 8, 16. Ooh. Divide by 4, x equals 4. Boom. That's your x value. Go back to your original OGs. One of these two. Which one looks easier? The one on the top or the one on the bottom? Honestly, it doesn't matter which one you pick. They're both going to give you the same answer. Personally, I would use the bottom one. That was actually easier to solve, but I'm just going to go ahead and do the top one. So I'm going to recopy the top one right here. So we have 3x plus 4y equals to 8. All of this you're copying on your notebooks. Sorry, I forgot. This is gone. You don't need that. So you're going to grab that x equals 4, dump it in there. So now we have 3 times 4 plus 4y equals 8. 3 times 4 is 12. Plus 4y equals 8. Barrier, circle, minus 12, cancels out. 4y equals, different sign, subtract. You have more negatives. There it is. Divide by 4, y equals negative 1. So then my solution is, remember, x comes first, then it's y. 4, negative 1, which are intersecting lines. Let me brief you on what we just did right now. This is all easy. This is everything you've learned already. It was this step. You always look at them and be like, do they look like the standard form? Do we have the x's and the y's on the left? If you do, then leave it alone. It's good to go. But if it looks like this, you have the x on the left, but then you have the y on the right. You need to fix it up first. Once you fix it up, it should eliminate, hopefully. And that's getting around substitution, because there's a different way of solving it, which is a substitution way. Students usually don't like that method. They normally stick with this. Makes it easier for them. Let's go ahead and do another example. Skip a line. Let's give you this one right here. Example 2. X plus 4y equals 6. Y equals negative x plus 3. There we go. That's this new problem. Okay. Hopefully you see a difference. Hopefully the difference stands out. Step 1, can you graph them? Well, can you graph the top one? No, that's in standard form. You don't know how to graph. But can you graph this one though? You could. But in order for graphing to work, both of these need to work. So that step is out. Boom. Let's go on the new step. Do these equations have the same form? Meaning, do they look the same? Are the x and the y's on the left side? Well, the top one is. That one's good to go. Well, is the bottom one, is the x and the y on the same side? They're not. So if they're not, let's fix them. So here we go. Let's go. The top one has the x and the y on the left. So that one's good. X plus 4y equals 6. Stack them up. Everything gets stacked up. So equals goes under equals. Well, the y is already on the left, so that's good. So put it under the y. So the y is right here. So we're going to put it under the y. The number is, this constant should always be on the right. So you always have to put it under a number, under the other constant. So it's under the 6. It's that little quitter, negative x. That little punk right here is messing the whole problem up. Easy. Grab this one, move it to the other side. And in order for it to move to the other side, you're crossing an equal sign. In order for you to cross the equal sign, you need to switch the sign of this negative x. Switch it. If you switch the sign of a negative x, it's going to become a positive x. And boom. There it is. You just fixed the equations. Now you can go ahead and do elimination method. So we're done with this step. Do the equations look the same? They don't, but we fixed it up by moving this quitter over here. Make sure that the variables are lined up. Line them up. Okay. Do any of these variables eliminate right away just by looking at this? No. Okay, let's go to the next step. Does switching the sides of the second equation work? If I switch the sides of this one, if that was positive, change it to a negative. That was positive, negative, change it to negative. Will something happen? Hopefully you said yes. So I'm going to change that to a negative. That positive now became a negative. And that positive now became a negative. And look at this. Simple. Cancel. Cancel. 4y minus y. Hopefully you said 3y. 6 minus 3. 3. Divided by 3. Divided by 3. Y equals 1. Jesus, this is easy. Go to your OGs. Which one do you guys want? The top one or the bottom one? It doesn't matter. I'm going to choose the top one. It doesn't have any negatives. So I'm going to choose x plus 4y equals 6. This is y equals 1, right? So grab it and dump it in there. So now you have x plus 4 times 1 equals 6. No, this is not 5. Some of you guys in class were saying it's 5. 4 times 1 is 4 equals 6. Circle, barrier, minus 4 minus 4, x equals positive 2. So then your answer is 2, 1. Intersecting lines. That's it. Yes, you could have used the substitution method. YouTube that, and then let me know if you like that method instead. But we went around the substitution method by fixing it up a little bit and avoiding all that mess. That's the substitution method. Pretty simple. Let's do another one. Oh, let's go over this piece. Look at this piece right here. 4 or 3 problems. Okay, let's give you this one. 2y equals negative 4x plus 8. 4x equals 18 minus 2y. Obviously looks way different. Super different compared to the other ones we've done so far. Here we go. Red pen, make sure it's a red pen. First thing, can you graph them? Oh heck no, you don't know how to graph this. It looks complicated. I don't even know how to graph that either. Well, I do actually. Next one, do the equations have the same form? Are all the variables on the left side? Because remember, don't copy this. Again, this is how a elimination problem looks like. All the variables on the left. Look at the first equation. Are all the variables or all the letters on the left? The y is not the x. Look at the second equation. Are all the variables on the left? Well, the 4x is not the 2y. So if they're not all in the left, If not, fix them. It's easy to fix. Okay? First of all, put the equal sign. Okay? This one's the little quitter. This little punk right here is messing you up. That little punk needs to move over here. Grab that punk. Move him over here. Move him over here. Okay? So if that was negative, then it's going to become what? Positive. And we normally like having the x's first. Duh, remember what letter comes first in the alphabet? X or Y? X. Is the 2y okay there? Yeah, it's on the left side of the equal sign. That one's good. Just bring it down. Boom. And the 8, that one stays there. That one doesn't move. Boom. There it is. You just fixed that equation. Let's fix this one right here. Well, this one's good. The 4x is good. So put it under the x's. 4x puts it right here. Oh, shoot. It wasn't a good one. Okay. This guy is the one that's messing you up. The minus 2y, right? Grab that punk. Move him over here. The minus 2y, move them. So if you want to move them, cross the equal sign, it's not going to become what? Positive. So it's now going to become a positive 2y. But you have to put it under the y's. They all have to line up. You cannot do this. Please do not do this. Okay, 2y, 4x. That's wrong. That's way off. Horrible. Horrible mistake. They need to line up. Same variables go together. That 18 stays the same. And boom. You already have your equation. Okay? Nicely done. Why don't you pause the video and try and see what you get? Okay? So next step is, do any of the variables eliminate? Not really. But if I switch the signs, will they eliminate? Well, let's try it. Change that to a negative. Change that to a negative. Change that to a negative. Oh, heck yeah. Look at this. Cancel, cancel. Cancel, cancel. What do you have on the left? A big fat 0. 8 minus 18. Negative 10. Is 0 equal to negative 10? No. So this is no solution. Parallel lines. And you're done. It looks scary. It looks scary. But once you start moving things around, it's actually easy. Let me do another problem. Because this was one that wasn't like really the problem I really wanted to show you. The result, well, technically it was. So you could get a special case. Let's give you another one. You know what they say, practice makes perfect. 3x minus 2y equals 9. Y equals 2x minus 7. That's your last example. I'm sorry, just copy it down. Here we go. Hopefully you already see a difference. Step 1, can you graph them? I can graph the second one, but I can't graph the first one. I can't graph the first one. I don't know how to graph standard form. Do the equations look the same? Meaning, are all the variables on the left? Well, the first one is, okay, the first one's good. Recopy the first one. 3x minus 2y equals 9. How about the second one? Are all the variables on the left? The y is, but is that little 2x that's messing this up. That 2x needs to come over here. Move over here to this side. Okay, let's just fix it. Well, the y is in a good spot, so put the equal sign always. The y is in a good spot, so just put it under the y, right here. It's that 2x that we need to fix up. We need to bring that positive 2x over there. You heard right. Positive 2x. So if that was positive and we need to move them that way, if that positive 2x will become what now? Negative 2x. And that y was originally positive. That minus 7 stays there. And look at that. Simple. It's a problem you already know how to solve, I hope. Okay, let's go through the steps very quickly though. We already fixed them. Do the variables eliminate? No. If you switch the signs, will this help you? Positive, negative, positive. Does that help you? Nah. So what you need to do is your secret weapon. Oh yes. We're using multiplication as your secret weapon. Okay? So you hopefully already masters at this. You multiply the top by a negative 2, multiply the bottom one by a positive 3. Okay? Remember, if you're multiplying by negative, all the signs in the inside change. So that's going to be negative now, positive, negative. Now let's just go ahead and multiply. Negative 6x, positive 4y. Eraser. 2 times 9 is 18. Negative 18. Boom. When you're multiplying by positive, don't worry, nothing cancels. I mean, the signs don't change. Negative 6x plus 3y equals negative 21. Okay? Can anything eliminate? Hopefully you said no. What if you switch the signs at the bottom? Will that work? Let's try it. So then let's change that to a positive, change that to a negative, change that to a positive. Now it worked. Hopefully you see it. Cancels, cancels. 4y minus 3y, 1y. 18 minus 21, different sign subtract. 3. There it is. Simple. 3. Get your original OGs. I'm going to get this one just for kicks. Y equals 2x minus 7. Y is 3. So y is 3. Actually, this looks way easier than the top one. Circle, barrier, minus 7, negative 4 equals 2x. Divide by 2, x equals negative 2. So therefore, my solution is negative 2, 3, which are intersecting lines. And that's it. This method gets around that substitution method. Substitution method is very complicated. This gets around with that. The only new thing you're doing is just moving all the x's and y's to one side and make sure that you have everything stacked up. After that, every step is easy. Could you eliminate? Switch the signs. And if it doesn't, use your secret weapon, which is multiplication. And that literally ends all the type of elimination problems that we could give you in middle school and also in high school. And the next type of videos are going to be your geometry videos, which are transformations.